it?
So we're looking at completing the square as a method of solving a quadratic equation. So sometimes you have situations where the equation won't factorize. Like in this case, you're looking at the factors of 20. You're trying to figure out which factors multiply to make 20, which also make -4. It's not going to work out. So completing the square looks at this part of the equation here. It says we've got to shuffle this equation around somehow so that we just have x equals. So it's kind of a trick way of factorizing. The first thing I would do is put the 20 on the other side over there, where it now becomes plus 20. We're just going to focus on this. And completing the square always uses the same method. You will take the square root of the first term, x. You will take half of this coefficient. So in that case, you're going to use 2 there, or -2 rather. And you just put that in brackets and square it. Now the reason you do that is if you look at this side note here, that will actually give you, if you multiply it out, it does give you x squared minus 4x, which is what you started with. The problem is, it gives you an extra bit there. So it gives you a +4. So it's not really true to say that this can be rewritten as this, because we've now seen that this, if you expand it, gives you an extra 4. So what you do, the completing the square bit, if you like, is a kind of balancing and saying, well, this does equal this if I just balance it out with a -4. So because the expansion gives me the extra 4, I'm going to balance it there with a -4. This square is being completed in that sense now. So now I'm just going to solve this like a regular equation, because I've got a single x I can isolate. So I move the 4 to the other side, so that's 24. I've got x minus 2 squared in brackets. Just solve this like a regular equation now. You want to cancel that square, so square root that, square root that. So now you've cancelled the square, you've just got x minus 2 equals the roots of 24. And now just add the 2 over, so let's just say that's 4.9 to 1 decimal place. Add the 2 over to the other side, and you have successfully isolated x. And you just need to take into account finally that you've got 2 different answers, because you've got positive roots and negative roots. So on the one hand you've got positive 4.9 and 2, gives you your 6.9, one of your roots. Or on the other hand you've got negative 4.9 and 2, which gives you the other root, minus 2.9. And there are your 2 roots. So in a way you can kind of think of this as these are the roots that aren't integers, which I wouldn't have been able to get through factorization, but have done so using completing the square.